Hey there, welcome back to the channel. So, I just completed the basics of LLDB, like just the basics. I decided to learn from the official documentation, like the tutorial one from the website, but I wouldn't recommend that because they expect like you know GDB. I didn't know that. If you do, then yeah, you can go ahead check it out. So I didn't know anything about like debuggers. I used to think like I don't need a debugger, I can just use printf statements, print, 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 and I can just debug anything. That's what I did for my earlier projects. But as this project is getting a little like out of hand, it's getting a bit complex, like the lines of code are increasing. Printf is not gonna cut it, so I decided to like learn a debugger. I chose LLDB because GDB doesn't have native support for Mac ARM architecture devices. So yeah, uh, I wouldn't recommend the official documentation. So I watched like an half an hour video. I have like like a few. Okay, you might not be able to see it, but like I have some commands. So just in case like I forget, I pretty much like I have I didn't just watch it. I have also practiced it, so I know like okay I can do it, but just in case they are like I just kept them uh, beside me, you can say. Why didn't I like okay. So let's just get started. So if I make debug this, yeah, okay. So LLDB, I'll give what executable do I want, and then you can say let's set like what are they called? Breakpoints, yeah, yeah. So breakpoint inside allocator.c. So the audio file that you were okay, I will just open here. So allocator.c. So what's happening is that let me show you guys what's happening. So where should I show you? Yeah, yeah. Let me just show you over here. So run as short short traces 0, and if I do this, yeah, I'll allow this. As you can see, wait, let me yeah, it gives us like a seg fault. And why is that? So let me just show you. No, okay, hang on, I need to go on. Okay, so string variable up. Are you looking at this? So this is saying like block size is 4071. So it's saying like the current value of the block size that we have is 4071. It should be 4072. Let me show you. So this is calling this is inside the function, as you can see over here. This is inside the function coalescing R. Coalescing R is the function which like merges the it doesn't check. There's another function to check, but what it does, it merges the current block that needs to be freed and the right and the sorry and the right and the free block that is on the right side of it. So this is what we have over here. So block size is block size minus one. Block the size variable here needs to be 4073. And why is that? So 4072 is the real space of the block, but I have added plus one to like denote like it's an allocated block. So like a LSB. And you will see why plus one because every single value, every single size value inside my code is 8 aligned, 8 bytes aligned. So there is no size that is odd. So if I like I don't need to allocate like okay, let me just show you what my sorry, so type def. So this is my you can say struct. So this is what it looks like. It's size, it's next, it's previous, and there's a footer block too. It has the same thing, just size, not the next and previous pointer. So this is a doubly linked list. As you can see, this is size value. If I had to like check if the block is allocated or not, I would have had to like add a bool around here, like this. So bool allocated, you know, but it's taking like extra space. Why do we need that? Instead, this code is 8-byte aligned. See, it's 8-byte aligned. So every single size value inside this is like even, you can say. It's a multiple of 8, so thereby it's also like even too. So if we check a block and it happens to have like odd size, that means it's allocated, and we just remove the one at the end, and that is the real size of it. So that's what it means. So when we insert coalescing R, it's a coalescing R. So that's what I'm doing over here. I know the block size, like the right size, is usually, I think I get it. Oh boy, I think I get it. How how was this like under my nose and I was like blowing this up? Wow, boy, I am down. Jeez. Oh boy, it's going to work, isn't it? If this works, I'm going to feel a little bit sad, but it's fine. Okay. This usually works. It's no big deal. Is it going to work? Sec fault. It's fine. Is the fifth core going to work? That's not working either. Fourth one, third one, second one, first one. Yeah, fine. It's not. Yeah, okay. None of them are. And that's fine. Let's check with this one. So short is let's take the first V1. Yeah, yeah, sure. So what I just realized right now, if you guys didn't understand, so coalescing RL, the function is only called when we. So this is here. So these are the two functions, which is a left field block and right field block. They return true or false based on like if the left block happens to be free, so it returns true so that it can be merged. If the right block is free, then it needs to be merged. So that's what we do. Oh, I realized one more thing. I'm dumb. Yep, I am dumb. I did not realize any secret thing. I'm so sorry. If anyone is watching, this is like 8 minutes in. Barely anyone watches, but if you are, I am dumb. That's what I'm saying. You know, I had like this epic moment where I realized, oh, I am so dumb, man. And then, oh, I realized my mistake, and this is such a brilliant move, and it was nothing like that. Okay, what did I do before that though? Yeah, okay, this is fine. So this should not work again. Yeah, okay, I get it. So let me show you my skills in LLDB. So LLDB, oh, I need to run this using make debug. Make debug equal to 1. So using this, we don't use like O3 optimization, just O1. Keep it basic, and let's go. LLDB and driver. Sorry. And this is the code. So we have to check at values like so. Okay, let me show you. Uh, what was that line number? 20211, right? Yeah, okay. Yeah. So what do we have over here? So we have some like we are getting like one value off, right? and that value is when the object is to be freed. When we are checking like that object need to be freed, it is having an additional 1 byte less. You can say like I shouldn't have said additional 1 byte less. You just one less byte. You can say it has one less byte. So where does it come from? Why did we set that wrong value? It's usually when we are allocating the block. So that's what we have done. We have set like checkpoints. So this is one block where we don't find the appropriate. So this is the code where we don't find the appropriate block inside free list. So we will add a breakpoint over here on the 213th line. So let's do it inside allocator.c on the 213th line. So we have one breakpoint on 212th line. That's fine. Oh, sorry, over here. 213th line, 38. That's fine. That is there. That's fine. So our another block is like this code where we do find the appropriate block, but it's like a lot bigger than what we need. So we need to split it. So that's what we will do. We will add another breakpoint over here at 252. So let's do it. So at 252. So we have another breakpoint at 252. That's fine. Sorry, sorry. And then we will add another breakpoint where we do find the appropriate block, but it's not like as big that we can split it. It's not appropriate to split, It's like less, like the space remaining will be less than 32 bytes, so it's not beneficial for us. It will be bad. So another over here at 266. Yeah. Let me change the values so I can like keep track. So 252, 266. I'm routing on my whiteboard right now. Okay, let's go. So I have three breakpoints set. If I look at breakpoint list, so we have three breakpoints, and now we will just start running. What was it called? Short traces, right? Yeah, yeah. Okay. Allow. Yeah. So we stop at the first breakpoint. This is the first breakpoint inside my malloc where we are allocating a size of 2040. Look at that. That is so easy. Like I would have had to like add so many freaking like print statements, and then I would have like remove a lot of them afterwards when this error is fixed. When this error is fixed, eventually it will take a lot of time, but still, I would have like had to add like a lot of print statements. That would have been really bad. Like a lot of time is wasted in that. Here I can just add like I can just say frame variable and boom. See all the variables that have been discovered here. Boom. Look at that. This space is not yet like done because this line hasn't been executed still. Hasn't been executed yet. So that's why we have null over here, and that's fine. We don't need that. This is the main thing. Look at that. So new HS is given as 2041. Why? Because new HS. So this is new header size is aligned size plus one. So we have already and correctly considered that our new you can say allocated block. So this is the allocated block because we didn't find it inside the free list. So this should also already have the LSB set, but I don't remember the full form of LSB. What was it? Uh, Least significant bit, right? Yeah, yeah. So here we set our least significant bit to 1. That denotes like this block is allocated. So yeah, this is correctly done. This is fine. Yeah. Yeah. So let's continue. So C will start executing the code line by line again, and it will only stop at the end of the program or if we reach a breakpoint. So if I do C, boom, the next breakpoint. Why are we still again over here? Because let me show you. So this is the first allocated statement, and this is A again. Since we don't have anything inside the free list, we'll again be calling SBRK and like it if you look at this, we'll be at the same position, See 2040, 2040, null, same thing. As you can see, but the pointers are different. 1028, 810. See, it's different, but that's fine. So I will go the footer. Sorry. You can also see the footer difference. So new footer starts at 810, but it is of 8 bytes. So this block ends at 818 and this block starts at 818. See, so our logic is working. One block is allocated over here, and right adjacent to it, this block is allocated, which is another 2040. This one. So yeah, 2041, that's fine too. Uh, this is going to take like a lot of time, but just bear with me. There must be some like shortcut to it, but I don't know. I don't know. Like I'm not gonna give it a like. It's just been 40 minutes since I learned LLDB, bro. So so let's continue. Yeah, now we are at a different position because we have free statement. So we have to free the first block. So yeah, what? Allocate, free one, allocate two. Oh yeah. We only added breakpoints to allocate stuff. Yeah. We didn't consider like 48. Yeah. Sure. So allocate to 48. Boom. Yeah, this is fine. Allocate a seed. This is fine. String variable 49. This is okay. Allocated as HS. Yeah. Total split useful space is 1960. That's sure. That's fine. Okay. Continue. String variable 4073 because we are asking for 4072. That's fine. And the block size is 2040. Yeah, sure. Which one? Why is my block size 2040? This is inside my mallet package. That block size is 2040. Why though? Hmm. Why is my block size 2040? It should be nothing, right? 4072. We allocate a new space. Yeah, and we don't care much about it. That's fine. Yeah, sure. Continue. Uh, Frame variable. Again, 4073 because of this. And we actually allocate a previous block. So yeah, useful space, we split it 6064. Total split is 1992, 30 minus 32 for header and footer, and 1960 is left. Continue the variable, and then we allocate 4072 again. So we have 4073 and block size. Look at that. Okay, this is garbage value. That's fine. And here block size was present, right? Yeah, sure. So sometimes block size is not present. So 72. No, that's fine. 4072 at the end. Block size doesn't matter. Yeah, that's garbage value. That's fine. New header, new footer, 4073. Yep, this is fine too. If you continue frame variable 2041, that's fine too. We need to find a block that is, what was it? 4171 something. Yeah. Should we speed run? Yeah, let's frame variable. C frame variable. C frame variable. It is supposed to be 4073, right? Coursework 4072 4073. Yep, that's fine. One thing greater than no, yeah, that's fine. So C frame variable. C frame variable. C frame variable. 2041. C frame variable. 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 This is like actually like a really good content. Like many people are going to watch this because I'm constantly saying like C from variable, C from variable. I should say something, right? It's like that meme. Are we there yet? Are we there yet? Are we there yet? Not going to bore you. Sorry. Uh, I should learn something. Like, should I risk it? Should I risk doing this? Not Safari. Multiple commands and LLDB. Oh, not that one. Uh, yeah, let's try. No, 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 okay, I don't want to risk it. So we do have C in variable, yeah. C. Yep, we reached it. We did it, ladies and gentlemen. We got it. So if I move up, frame variable, look at that. Boom, 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 boom. Garbage value. Why did that happen? Not sure, but let's find out. So this block was supposed to be at 15,000 something. Yeah, okay, not this one. This one. Look at that. So the same HS has been kept. So it's a value that was set. Same HS. So here it is. So same HS. Look at that. So header size is plus plus. Yeah. So same HS and same FS is 4073. So it's set. It's done. Okay. Are we done this piece? Yeah, correctly. Okay. So this is the header. That's fine. This is the header. That's fine. Block size is 4071. Okay. Let me get this. Let me get this. So the space starts from 15, like the 18th byte. It's nice that we have like a lot of zeros. It's like easy, you know. That's fine. This is correct. This is also correct. The block pointer starts from 15,000. Whatever this value is. 4071. Why is the block size read as 4071? It should be 4073, right? What does it look like? Um, into binary. I should say decimal to binary. Come on. 4072 looks like this, and 4073 is just one. Yeah, okay. And 4071 is just, yeah, 4072 is this, 7 is this, 4073 is this. Yeah, sure. Why is it read as 4075 inside coalescing R? So inside coalescing R, we have block size -1. This value should have shown us like 4073. This will it doesn't make sense. We are setting it as 4073. Like look at this. It is 4073. We know for a fact it is 4073. And then when we are trying to coalesce it and we get the block size as 4071, which should be 4072. Because of that, like entire you can say uh, entire pointer arithmetic is messing up. Look at this garbage value. Hmm. Why is this happening? Why do you decide to do that? Is this bit flip? Is this because of the cosmic universe? Why is this? Okay, why is this? Why is this? We did not we did not touch that block, right? It was at the end. There was F4, it was allocated and it was freed easily, like, quickly. Let's check who else touches that block. That's great, right? Let's check like who else touches that block. Let me do a dry run. So I'll do it on my whiteboard. Should I show you guys? Yeah, I'll show you guys. So sorry. But I have commands in there. Yeah, I'll show it in the bottom. Yeah, that's fine. Yeah, I'll show it over here. That's fine, right? Okay, I should know. Yeah. So first so let's say this is our heap. Uh, it's definitely not a good looking heap. So we first get a value of 2040. We allocate it over here. Then again we get a value of 2040. We allocate it over here because our free list is empty. But then we deallocate this, and boom, this is freed. So our free list starts from over here. Great, great. Then we are asked to allocate 48 blocks. So what we do? Well, we don't need to call don't need to like call OS again, right? We have a free block of 2040 over here. So we allocate 48 from it and we leave 1960 here, like the split block. So this is fine. So then we have, what is it? Free one allocate to 48. Yeah, this is done. Allocate 34072. Yeah. Then we are asked to allocate a block of 4072. Well, this is our only free block and it's 1960. It is of 1960 size. So we can't allocate 4072 over here. So we call syscall 4072. Well, actually, we don't necessarily call this syscall. It's not like if I'll show you the implementation of memSBRK. It's like we have already asked for more than enough size from the OS, and then we are just moving a single mem SBRK pointer forward and backward. That's what we are doing. We already have like 20 MBs or 50 MBs reserved. So we are not calling Linux kernel to allocate space. So 4072, we allocate over here. Then we are asked to free it quickly. So if we free this and keep two blocks, that's not optimal. That's a bad case of external fragmentation. So it is beneficial to merge them. When we merge them, they together become a block of 6064. How did that happen? Well, you can add both of them, and then you can add two headers and two footers because they don't need it anymore. Well, not two headers and two footers, just one header and one footer. So 1960 plus 4072 plus 32 will give you this value. So this is block, and then we allocate another 4072 block. So 4072 is added over here, 4072, and then we are left with 1960 again. This is the only free block, and then we are asked to free up the zeroth block. So we are asked to free this one. So now our free list looks like this, and then free zero, then free two. Yeah, we are here to free this one, but since this is adjacent, we merge them. After merging them, we get 2128, I guess. Yeah, and then free two is done. Then we have, what is it? A54072. Yeah, over here, 4072. And then this is allocated, and then we free F4, so we free this one. After freeing this one, this is like a big merge. So because its left side is free, right side is free, and this middle one will also be free. So we merge all of them. After merging all of them, sorry, I don't remember the value, but let's say this is a big value, something like 10. What was it? 4072, let's do the math. 4072, 2128, and 2040. What was it? Oh, I don't remember. Let's fine. Let's call it X. And then this block is freed. So this is where the problem is. This block. Who else is touching it? No one. To get the value of this block, we are calling 4072 like the new block. Let me know it, right? Let me show you guys. So the 4072 that we are having problem with is this one. Where did it go? So this is the 4072 that we are having a problem with, and it is seen HS. Why did it go under same HS though? This one also went under same HS. This one also new HS. Wait, now that I think of it, so allocate to 4072, allocate 4072. Hmm. Free one, allocate two, allocate three, free two is supposed to do is um, 2 and 2 8, allocate to 48, allocate 5 as 4 6 1 2. Why did they go under C matches? They shouldn't go under C matches though. Why did they do it? Am I audible? Okay, so let's do a little bit of debugging. So we go over here 2040. It's new block, yes. Again 2040. It's new block, true. Then 448, it's split block. So we have allocated header footer. Allocated is this, and split is we don't have split over here. But yeah, let's say useful space 1960. That's fine. Let me do the thing again. For my sense, I won't bore you by showing you guys this again. But okay, no one really watches this. No one really watches like till even this. What is it? Half an hour, yeah, 37 minutes. No one's going to watch this, but yeah, if you're watching this, thanks. Uh, if you're watching this, I want you to quit this video. Like, stop, get some help. You know? No. But seriously, uh, thanks for watching this far. You know, I would honestly recommend you to like go and do your own thing. Like go ahead, write, work on your own project or something. You know, this video isn't that interesting in the future. Like it's already night. It's past 12, and I'm like starting to feel the uh, like I haven't slept great for the past 2 days, and then this now I can sense this uh, sleep coming towards me. Like I can feel like getting myself sleepy. I'm getting a bit. My head isn't working at a better efficiency, you can say. It's not going to be great. So thanks for watching. If you are watching this, um, yeah, work on your own stuff. Quit this video right now. Quit it. Yeah. Thanks for supporting me though. So, ah, okay, this is okay. Yeah, 2040. This is fine. This, 48, 4072, 1960. Boom. So 4072 is allocated and then it's freed, and then when we ask for 4072 again, it's just giving the split block. That's correct. That's correct. And then, sorry, and then we are asked over here, free 0 and free 2. It's just 2128. So, So 2128 we have, sorry, so we have 2128, then 4072 that we get, it's perfect. So then we are asked to free up the block, free, no, 4072. Then we are supposed to allocate 4072, the 4072. So this 4072, so uh, thing that we get over here, 4072 and 1960, this is allocated, this is fine. For this 4072 is supposed to be new, so that's correct. And then we free up this, right? And then we free up this. This is freed F4. This freed a big module, a big block, and then we free this one too. Free 4, free 5. And then it's 2040 back again. Yep. Who is touching that block? Not sure. Who is it? Who is it? Who is it? Why shouldn't sing that song? I'll get a copyright. If we take a look at it, the pointers should be the same because it's like this is like the reiteration of stuff, right? So let's say 2040. So 2040 2041 818 3038. So if you look at it, uh, 2040. Okay, shocking. Why though? Wait, 2040 818 3038 1028 3038. Why though? Why did you decide to do that? Why did you decide to do that? Why did you decide to do that? Hmm. Hmm. Split pocket, split pocket. Yeah. Oh, I was looking at another thing. Yeah, yeah, sure, sure, sure. 810, and then we have 818 1028. Yeah, let me write that stuff down. You know, easier. So 810303. Not again. 0 to 810, and then we have 818 1028. Then we have 818 860. Then this is 1030, 1030 2030. Yeah, 2030. Let's verify this much. So yeah, 0810, this is fine. 8181 818 860, that's fine. 1030 2030. 868 1868. Okay. 868 1868. 2030 2038. Yeah, and this is the end. This is the end. 868 1868 and then 2030 3038. Yep, it's working. And then we just rehash it again. My three goals in hours, skip block. Let's go inside. Listen, let's make some change inside coalescing iron. Coalescing R, just R. So inside coalescing R, they will keep a pointer, white pointer, heap high is equal to mem heap high. How about that? Sorry, I don't really want to run it. And then LLDB and driver, what is it called? I forgot. Reset. Yeah, just run this short traces. I just want the value. Yeah. What is it? Main variable. Yeah. So we get in heap high as this, and then we get. Yep, I knew it. So okay, look at that. This shouldn't be allowed. There is nothing on the right side. It should be greater than or equal to. This should be greater than or equal to. Let's check what happens now. Yeah, it's not ending. Oh, why is that though? If there is no, if it can't look for high, heap high. The first block when it's not allocated, if it's equal, it won't grow. What's causing it? This needs to be equal, right? I don't get it. This needs to be equal. Because if our right block starts from the end of the heap, we shouldn't be looking at that block, right? There is nothing over there that needs to be freed. Duh. Let me do one thing. What was it called? Don't remember. Yeah, heap five over here. Yeah, this over here. Right after this, or we shouldn't be inside the right block, right free block, right? 'Why is this happening? So 15, 6, 8, 0, 0, 8. We're getting pointer. Pointer is at this. 18 ahead. Hmm? 18 ahead. What? Huh? Huh? I'm thinking clearly. Why is it 18 ahead? It should be 24. What? 6 this. Is it something related to eating? Yeah, yeah, it should be X to decimal. Yeah, okay. Yeah, yeah. My bad, my bad. That's correct. 4073. Why are you doing this, bro? Why are you doing this? Who is doing that to you? Can I set a watch point at a specific address? Is that possible? If it is, oh, oh boy, let's do it. How to set watch point at memory address LLDB. Let's go. If that is possible, we are winning. Watch points and memory address. Let's go. Watch location this. Doing the same in with the new change from GDB to LLDB. I can't find a way to how to set watch points and memory addresses in GDB. I used to do this. Yeah. Okay. Watch point set expression. Let's go. Let's do it. Let's set watch points on that thing. Whatever. Yeah. Okay. 4071 watch point at that location, right? Yeah, okay. Got it, got it, got it. Yeah, let's do it. Squid, boom, boom, LTV and driver, uh, breakpoint at, what is it? Allocator.c 211, breakpoint at allocator.c 252 and 266, run dash of short traces, videos. Yeah, don't want this, don't want this either. This is 48. This is 2030. Most probably, let me check. Yeah, 868. Oh, sorry, this one. 1870, is it? Yeah, it's the same thing. 868, 1868. Yeah, okay. And I want this one, just this one. Yup, perfect. So this is the 4072 that I want. Because after this, it's going to be like, okay, let me show you. See, it's going to be 2040 again. So I'll set a watch point on this memory address. So new HS. See, you're looking at. Wait a minute. New HS. Okay, so I get a new block. Is BRK header align size. Sorry. Yeah, sure. Now that I think of it, 1,000 difference is like a lot. What is 1,000 in this? 4096. Yeah, sure. Yeah, okay, 4096 is short, that's fine. But why this? So 4072, so new FS, there is some problem in calculating new FS. So we have new block, which is this, mem is PRK. We move ahead by header, and then we move ahead by footer again. Sorry, by line size. Yeah, yeah, sure, sure, sure. New header is at this, new footer is at this. New header is 4073 and new footer. What? 72 plus 32. What is it? 4072, right? 4072 plus 32 equals to 4072. We ask for additional things. There was no such error previously, right? 4073. Yeah. Why this? Let's try that again, right? Maybe it's a one-time thing. So, what is it called? Running short traces 0. Oh, I forgot the breakpoints there. Breakpoint at allocator.c 211 allocator.c 252 and then 266. When we run this again, we have sorry, sorry, sorry. CLL frame variable. variable C, variable C, variable. Yeah, look at that. This is completely random. Why are you doing this? Why are you doing this? This is third, bro. Only the new thing is doing that. Why am I seeing garbage values? Yeah, which 4072 was it? Oh, I forgot. Uh, so yeah, I haven't seen much. Okay, so yeah, what was I going to run? LLDB and tribal. Yeah, breakpoints that are. What was it called? Breakpoint. Yeah, repeated. Yeah, it forces 7.1 block was 13.4.00, which is the first allocation. Sorry, this is the first one. Yeah, this is the first one. First, I did not do variable, right? Okay, sure. 2040, sure. 48, 4072, which is this one. And then we free it, and then we again allocate 4072, 4072, 4072. And then this last 4072, which is this one, which is at address 13400. Which one was it? Oh god, which one was it? 13400. This is the first thing. I am tired. I think I'm ending this video right now. I'll look it up tomorrow. I'll record this again tomorrow. But yeah, we did a lot of things. We were successfully able to waste a lot of ink, and yeah, that is it. That's what we did. Okay. So thanks for watching this video. I'm Aditya Bachorni, and I'm an engineer for fun. Bye.